we can see the output with 10 values: customer, customer address, and so on. This means we have access to all 10 tables in the schema. Now that we have the tables, let's copy them over. In the activities section, we can use the for each activity. Now we're going to drag that in, and you'll see a few options like on success, on fail, and on completion. If the lookup is successful, we want the for each loop to run, so we connect the green arrow to the next activity on success. Inside this for each loop, we want to copy data. For the source dataset, we'll use the same SQL Server on-premises dataset as before. But for the query, we don't want to select a specific table. Instead, we want to use a query. This query will dynamically change for each table in the loop. In the dynamic content section, we'll write an expression that concatenates the schema and table names. It says, concatenate, select from schema, table name. This expression takes the schema name, sales LT, and the table name, address, and dynamically generates the query by adding a dot between them. This allows us to copy each table individually. After creating this query, we click OK. Now, for the sync part, we're going to use the same one as we made before for the sync, except we'll click on Open because we want to modify it. We want to change the file path directory to be bronze as the top layer. So, that's the bronze container that will hold any bronze data you want to bring into the data lake. Under that, we want to define the schema, which is sales LT. So the structure will be bronze sales LT as the folder, and then within the sales LT schema, it will be the name of the table, like address. Finally, the file name will be address.parquet. This will be the structure we're after. To get the schema and table names, as you recall from the first part of the source, we can concatenate them together within this query. This is a good way to get the two layers. We can also get the schema name and table name. For the sync, it's a bit different. We need to go into the sync dataset, open it up, go to the parameters, and create parameters for schema name and table name. After doing that, we'll go back to the pipeline, and you'll see these parameters now available for the sync dataset. The values for these parameters will be added using dynamic content. For the schema name parameter, we add dynamic content and use the expression item.schemaname. We'll click OK. For the table name, we'll do the same, but we use item.tablename and click OK. This allows us to pull the schema and table name values through. Next, we go back to the sync dataset, open it up, and go to the connection. We need to update the file path to use dynamic content. We'll use the concatenate function to dynamically create the file path. We'll concatenate the dataset schema name followed by a / and then the dataset's table name. This creates the dynamic file path for every table. For the file name, we'll again concatenate the dataset's table name with the .parquet extension. This way, the file name dynamically changes for every table. Now, if we go to the pipeline view, we have the for each activity that copies the data. It runs on success of the lookup, but it doesn't automatically pass the schema and table name. So, we need to explicitly tell the for each activity which items to iterate over. If we click on the middle of the for each loop, we can see the output of the lookup activity, which contains the data we need to process. We had run the lookup, and in the output, you can see that there is a value item within the JSON object. This is the item we want to reference because otherwise, if we just said for each, how would it know what to iterate over? On the for each activity, we click on the activity and go to items. I had previously done this incorrectly. It's not values, it's value. That's why there was an issue with the outputs. If we leave that as value and click OK, we have set it up to say on the lookup activity to get the value of that JSON object. Let's click on lookup and then click debug. This should run the entire pipeline. However, a failure happened on the source side due to incorrect syntax from sales LT. We're missing a space. Let's go to the source and check.
it says select from, but there's no space after from. Since the query is concatenating the strings, we need to add a space in there. After adding the space, click OK. Next, we can go to the copy activity and ensure everything is set up properly. Once we're ready, let's click Publish to save and publish all changes. Once the changes are deployed, we'll add a trigger. We can trigger it now to run it immediately, or we can set up a scheduled trigger, such as running daily or when the SQL database on-prem is updated. For now, we'll just trigger it manually. After triggering, we can monitor the pipeline. We can see the pipeline here under manual trigger, and if it was scheduled, it would say scheduled trigger. It will show as in progress, and we can click the refresh button to see the progress. If we click on the pipeline name, we can see all the activities running, including all the copy data activities running concurrently. We can refresh to see which activities are still in progress or have succeeded. There's an error with one of the activities, but others have succeeded. If we preview the output, it shows success.
For the failed activity, we can see the error, which states that an ID was not specified. Let's refresh and see if that resolves. We can also go back to the storage account, refresh it, and navigate to the bronze container. We notice that only the schema name and table name are showing, but no data is being pulled through dynamically. Let's go back to the pipeline, open the for each activity, and double check everything. It should be fine, as we have specified activity lookup and output.value. We'll edit the copy data activity, particularly the source, and verify the query syntax again. Should be all good. So that's fine on the sync side. Let's see here. I don't know if this has worked dynamically. That's it. Yes, there was no I symbol. There we go. Okay, and then we go back, and that should work now. So we'll publish all, click publish, then go back to the main pipeline and run it. What's happening is that it requires the I symbol for the dynamic content. If we go back to monitor, we can then track the pipeline again. Click refresh to see the status of the copy all tables. We can see that it's running and a couple of them are in progress. Now we can go back to the bronze container and check. If we go to the top layer, we can see sales LT. It's working now. You can see that it's creating the folders, and inside these folders there's data like address.par. If we go back out and refresh, we'll see more data coming in as it processes. Everything is working, and we can see the files are being created in the storage. Once we refresh, we can confirm that it ran successfully. We've now created a pipeline that looks up and accesses the SQL database using a username and password on-prem, gets a list of table names, and then copies the data of those tables into an Azure data lake. This completes the ingestion process up to the bronze layer. In today's video, we'll cover Databricks for transforming data from bronze into silver and from silver into gold. Let's get started. First, we'll go to the Azure portal and open Databricks. To get there, we'll go to the resource groups and find the tech group. Inside, we'll have our Databricks workspace. We can launch the workspace, similar to Data Factory, and it will use Microsoft Entra ID to log in using your email. Apparently, I didn't have access to my own Databricks, but after refreshing, I was able to get in. On the left, there's a bunch of options, but we don't need to worry about them right now. What we need to focus on is leveraging workspaces and compute. But workspace is, as I've said before, a space for your work, for your notebooks. Now, compute, which is the other thing we're going to be aware of, is where you can create the underlying compute infrastructure to run your notebooks. Why do you need this if it's just a notebook? Well, you're doing an ETL here, or an EL, whichever it is you're using Databricks for. In our scenario here, we're doing an ETL, so we're extracting the data, transforming it, and then loading it, extracting using Data Factory, transforming in Databricks, and loading with Synapse. So, we need a cluster here to process the information. Although our database is small, in the real world, this could be petabytes of data, which is a lot. So, first things first, let's create this cluster. We'll change the name to just inch cluster. This is fine. Access mode will be single user since it's just us and we're not sharing it. We'll use the default Databricks runtime version. As you can see, there are standard options as well as machine learning versions with GPU, but we don't need that. For the worker type, we're selecting the compute resources we want for the worker. You get different types here, including general purpose, accelerated, and optimized. We just want to go for a normal general purpose option, the lowest we can get, which is 144. Click on that, and that will do. Now here, we'll terminate the cluster after 120 minutes of inactivity, but let's bring it down to 30. This means that if you don't use this compute in 30 minutes, it will shut down, but you have to wait for it to load again. If we set it to 10 minutes, sometimes if you're debugging, it can be annoying because you'll come back and it's shut down, so you'll need to wait for it to reload, which defeats the point. Setting it to 120 minutes would just cost more money than necessary, so we'll keep it at 30 minutes. Now for advanced options, we want to enable credential pass-through for user-level data access. This will allow users to automatically pass through credentials to Spark, enabling them to access data in Azure Data Lake using their own credentials. Let's create the compute. Once we click on this, we can see that it's finding instances, which could take about 5 minutes. While that's happening, let's click New and create a new notebook. As you can see, it's similar to a Jupyter notebook with different code blocks. You can see here that there's a Python option, but you can change the block type. For example, one block could be a SQL query, another could be Markdown for titles, and another could be Python, which is really handy if you want to switch between them or if you're more proficient in one than the other. Anyway, we'll just choose Python. Now that we've created the notebook, we'll change the name of it to Storage Mount. The reason for this is that before we can start using the data lake storage, we need to mount it to the cluster. You need to have an access point to the storage. While I do have a repo with all of this, I think the best way to learn is by writing it yourself to get that muscle memory. But I'm going to copy and paste the code. Are using a Mac, you can screenshot and then copy and paste from there. So essentially, we are configuring this to be mounted. This is the container we're wanting, which is bronze, and then this would be the container name. If we go back to the portal and go to storage accounts, let's see what it's called. InchSG. So we'll update this to be InchSG. What this means is that this will be our mount point. So if we access there, we'll get the data that's in there. If we click the play button, that will run the code. We don't want notifications, and now you can see this pops up asking to start the compute resource. I'll cancel that, but that's what I meant. It doesn't automatically run in the notebook. Up here in the top right, you can see we can connect a cluster. So we have this cluster. If we click on that, it will now start the cluster. This may again take a couple of minutes while it starts all the nodes up that it requires. But now, when we run, we have the compute resources to run the notebook. Apparently, I'm not allowed to do it, so I've terminated this because I found what the other issue is. Because we're in the trial version, we can't use multi-node, we have to use a single node. So we come to the compute section and select the cluster we created. There's a multi-node and single node option. We want to go with the single node because multi-node is not allowed in the trial version. So we can click on compute again, create a new compute, and call it inch single node cluster. Everything is the same as normal. Here, we're going with 144, terminating after 30 minutes, and enabling credential pass-through. This allows us to mount it, and then we click Create. It's been about 5 minutes, and it's still going, so we'll go to the workspace and look for Storage Mount. While it's doing its thing, let's add another code block. In this block, we'll mount the exact same code, except the one change will be silver. So, our mount point is M silver, and then the next one is M gold. Again, it's InchSG and DFS core Windows.net. These configs are standard, and if you're wondering where I got them from, it's from this page here. As I told you, Microsoft's documentation is always well done. It's for accessing Azure Data Lake storage using Entra ID credential pass-through, which is what we're using for this example. If we scroll down, you'll see Azure Data Lake Storage Gen 2, and here's the code straight from the Microsoft website. Let's try to connect it. It should be starting that single node cluster now, if that makes any sense. Once it starts, we can run this and it will mount them as I had said. Hope this works. Something that could be good for you to know is that within the notes, I've documented the source for another way to do this. As you could see there, this is the legacy method, so it's not the way you should do it now. If we go back to the top, you'll see the new recommended way. These are just the notes for how to do the entire process. You're able to find in the repo to help guide you a little bit. If we get to Databricks, we can see there are actually two solutions. One is mount, and the other is enabling a bunch of other things, which I can show you here. This is another data engineering project that I had done. It's the exact same format, just for my own understanding. This time, the configuration is actually using a client and secret ID. If you want to find out how to do that, there is another tutorial you can check out, which I'll link at the bottom here. It's the same as the repo, and in that, it talks about how to do it the other way. Hopefully this will be done by now, but it's still going on. Let's see if it's even loaded up. Apparently not. There's nothing exciting here, but you can trust me, this will mount and list out. We'll show you in a minute. In the meantime, we'll go into the workspace where we have this storage mount. You can see there's create, which is what we had done last time. Instead, what we're going to do is import the bronze to silver notebook. If we open this up, we'll see that we have two bits we're going to work on. First, we'll do a single table column transformation, just to show you how it works. After that, we'll do the data transformation for all the tables. We start from the top with the dbutils FSLS, which lists what's in the mount, like SL bronze, SL sales, LT, etc. If you recall, here we have the bronze container, SAL LT, and then these are the tables. For a specific one, it lists all those tables in there. We also have another one that lists what's in silver, which is nothing yet because we haven't moved it in. Now we create a data frame where we load in that Parquet format table, and then we can display that data frame directly in the notebook. Here's the data frame shown as a table, and you can see it has all the different values. This is good for displaying when you make a transformation. For example, if you change a column name, you can display the data frame and see the new name and updated values, etc. That's not the most efficient way to see a name change, but it's an example of what you can see. Now, we're importing these functions because we're going to use them to change the date format. As you can see above, the date format is a bit messy. It's year, month, day, then time with seconds, plus the time zone. That's not very nice if you want to see it in a Power BI dashboard. You wouldn't want your dashboard to display the date like that. You would probably prefer the format to be year, month, day, because that is easier to read. I've found personally that it's the best way to sort, because when you do it with day, month, year, like day, month, year, in a file directory, it can get all mixed up when you try to sort it. So here, what we're going to do is cast it to this format, change it, and then do dfbot with column to modify it. We'll say, in the data frame, get the column with this name and change it to the new format. Then, when we display that data frame, you'll see it modified to the new format. This shows how to do it for one column. We can also quickly do an example with SQL, as I'd shown before. The language used is dynamic, meaning you can change the language the SQL leverages using something like percentages. And as you can see, it selects one column and shows it. Now we want to do this date transformation for all the tables. For every table and every column that has a date, we'll change that date into this format. First, we create an empty table name array. Then, for the listing, we append the first value, which is split by the /. This is to get the name of the table. For every item listed out, you'll want to get the name, split it by the /, and take the first item. So for instance, you're extracting each of these names and splitting them, then taking the first portion. This process allows you to create a list of table names. Now that you have the table names, what we want to do is change the column format for each table. We'll set the path to Mount Bronze SLT or Sales LT, and the format will be table name /SLT name and then .parquet. This is the format the data is stored in. For each of those tables, we load the data frame and read it as a Parquet file. Then, we get all the columns in the table. For each column, if the column name contains date, or date is in the lowercase version, we'll change the date format to the desired format. Next, we set the output path to mount Silver Sales LT with the same format as above and write it into Delta format. Delta format is built on top of Parquet with additional features like tracking, version control, and schema changes. When we display the new data frame, we can see it's a different table because it's the last one in the list, e.g. sales order header. I'm going to go back to the workspace and go to storage mount. This should be all set now, so let's run the code. We've written it wrong though. It's in tech, not in. So there you go. We can see that in the bronze it has this here. If we done bronze sales LT and run that again, you can see all the different tables, and then this is mounted in silver and gold. Now that they're mounted, they're available in this workspace, and in a different notebook, we can connect to the same cluster and just run everything from the top. Now it's able to access the data that we mounted in the other notebook. This shows how powerful Databricks is. It reads the file, displays it, and just ensures everything runs normally. It updates the data, and we can see that it changed as expected. We scroll to the bottom to confirm everything is running fine. The reason the outputs were already here is because I exported this notebook. To export it, you can go to File and select Export as IPython Notebook, which will export the notebook in its current state. If all steps failed, it would export it with the failure messages. If they all succeed, it would export it with the success messages or outputs. After running the transformations, we go back to the workspace, open up the container, and check the silver folder. We can see Sales LT now exists. Let's open that up, and we can confirm that all these tables exist in the correct Delta format, which is how Delta works. We don't have to concern ourselves with it too much, but the gold folder is still empty. Now that we have the data with the date looking better, I think it would look even better for Power BI if we change these to have underscores between the names, e.g. JDate should be JORDate. These are simple transformations, not something you'd necessarily do in a company, but it's a good exercise to understand how transformations work. I'm going to import the silver to gold script again. You can import it using the GitHub link below, but I strongly recommend typing it out yourself. I've imported the extended version of silver to gold because it includes both the single table and all tables transformations. We'll go through the exact same process, starting with a single table column transformation, then changing the column names, and eventually applying it to all tables. This time, however, we're going to wrap it in a function that we can call directly when processing all the tables, avoiding code repetition. Let's list the Silver Sales LT tables, and we can see that they exist, which is good. Then, we list the gold folder, which is empty, as expected. We'll now read in a table as a data frame, getting the data from the Delta format, and display it. We can confirm it's the updated silver table. Next, we get to the function that performs the transformations. The general idea here is to convert camel case to snake case, which is a common formatting style in programming languages, especially for functions and variables. For variable names, etc., the function takes in a data frame, changes the column names, and returns the modified data frame. You can pause the video here to read the comments, which I've generated using ChatGPT to make it easier for you to understand what's going on. Essentially, for every column name, it changes it, ensuring there are no duplicates, and then it renames the columns using the new names before returning the data frame. The general usage here is that because the function returns a data frame, you need to assign it to a variable. You do this by setting the data frame to the return value from the function. You pass in the original data frame, and it gets assigned to this new variable, allowing you to use the updated data. When we run this, it assigns the data frame the value of the renamed columns. If we display it, we can see that all column names are now in snake case with underscores. Now, we want to apply this to every single table, which is similar to what we did previously. We first create a temporary table name list, but this part isn't strictly necessary. I'm just showing you what happens here. When we run this code, it appends the list item using the file system function in Databricks, and the output shows the file paths, similar to our bronze to silver process. Next, we'll use the function rename columns to snake case as defined earlier, to rename the columns to snake case for all the tables. We assign and append the table names, and that will give us all the necessary data. As we did before, we'll apply the function for each table, and this time we'll output the transformed data to the gold folder, still using the Delta format. When we run this, we see the paths pop up as expected, just like before. The print statements in the code help us visualize what's happening behind the scenes. Now, we have the data with the new column names in snake case, and you can see the last data frame displayed corresponds to the sales order header table, since it's the last one processed. That's how to perform transformations and use Databricks effectively. The next step is to automate the process so that these Databricks notebooks run automatically from the pipeline. To do that, we go back to the portal and proceed with setting it up. In Data Factory, we will launch a studio and go to the pipeline we were creating in the previous episode, which is for copying all tables. Our goal now is to create an activity that will run the notebook after the previous activities have successfully run. To do this, search for Notebook, and you'll see options for both Synapse and Databricks. Drag and drop the Databricks notebook into the pipeline. Set it to run on success after the previous tasks, and change the notebook name to bronze to silver. Next, we need to set up a linked service for Databricks. This is necessary because Databricks is a service that requires linking. We'll configure the linked service with the appropriate integration runtime, which is an auto-integration runtime in our case. Select your Databricks workspace and specify the cluster. We'll use an existing cluster and set the authentication type to access token. To obtain the access token, go to the Databricks settings under Developer Settings and choose Access Tokens. From there, you can generate a new token. Provide a name for the token, such as the project, and set its lifetime to 90 days or whatever suits your needs. Once the token is generated, make sure to copy it immediately because it cannot be retrieved again once you navigate away from this page. Since this token is sensitive, we'll save it securely. Head back to the Azure portal and open Key Vault. In the Key Vault, create a new secret and paste the token there. Once it's saved in the vault, go back to Data Factory and choose Azure Key Vault as the key source. Select the Key Vault and the secret for the Databricks token. After connecting the Key Vault, you can select an existing Databricks cluster. Choose the desired cluster, in this case, our single node cluster. Test the connection to ensure everything is working and click Create. In the notebook settings, choose the connection you just created and select the notebook to run. Browse to the notebook in the Databricks workspace under the Users section. Find the bronze to silver notebook and select it. Click OK. Now, the bronze to silver process is set up. You can repeat the same steps for the silver to gold notebook, setting up a similar activity in Data Factory. After selecting On Success, rename the activity, select the same linked service, and choose the silver to gold notebook to run in the same manner. Now, let's go back to the pipeline, select the silver to gold notebook, and click OK. Once we've set up both notebooks, we can publish everything to save the changes. To test the pipeline, click Trigger and then select OK. This will initiate the pipeline, and you'll see a notification at the top. Click View Pipeline Run, which will automatically take you to the monitoring page. You'll see that the pipeline is in progress. If you click on it, you can observe that the activities are being executed. For instance, once the For Each activity completes, you'll see that it has finished running. If we refresh the page, we can see that the bronze to silver transformation is in progress. You can click on the glasses icon to get more details. This will take you to a run page where you can monitor the notebook's progress. When the notebook finishes running, you'll see that it's done. Now, We refresh the page to check the status of the silver to gold transformation. Again, you can click the glasses icon to monitor the run, and once it's complete, you'll see that it was successful, along with the start and end times and other useful information. After both transformations have finished, the pipeline run will show as completed. When multiple jobs are running concurrently, you also have the option to view them in a Gantt chart, which can be handy for understanding the execution flow and the timing of each activity. With that, the transformation process is complete. We've now added the bronze to silver and silver to gold notebooks directly to the pipeline.
In the next part, we'll load the data using Synapse Analytics for the final part of the ETL process. To do that, go to the Azure portal and navigate to the Synapse workspace. Under Getting Started, click Open Synapse Studio to launch the Synapse Analytics Studio. The interface is similar to Data Factory, with some extra features. On the left panel, you'll see options like Home, Data, Develop, Integrate, Monitor, and Manage. Under Data, you can create databases and perform tasks similar to SQL, like loading the data. In the Develop section, you can create SQL scripts and manage your data transformations. You can create scripts and notebooks in the Develop section of Synapse Analytics and use the Integrate section to create pipelines, link connections, and monitor different pools and pipelines. In the Manage section, you can manage pools, security, triggers, and linked services. Now, to load data into Synapse, go to the Data section and click on the plus sign to create a new SQL database. You'll be prompted to choose between a serverless or dedicated SQL pool. If you expect high data volumes, a dedicated pool might be better, though it's more expensive. For this example, we'll use the serverless option and name the database GoldDB. After it's created, you will see the new database under SQL Database in the workspace. Once the database is created, you can link your Azure Data Lake Gen 2 storage. Under Linked, you'll see the storage linked to Synapse, and you can browse it as if you were in the storage account. You can see the bronze, silver, and gold datasets and browse these directly. For the next step, you can right-click on individual tables, select New SQL Script, and run SQL queries directly within Synapse. For example, if you're working with Delta format files, you can set up the script to query the top 100 rows from a table. Synapse also allows you to connect to different compute resources and change the database you're using. For instance, if you have multiple databases like bronze, silver, or gold, you can run queries on any of them by selecting the appropriate one. Let's create a view in the gold database. If you update the SQL script to create a view instead of querying the table directly, it allows you to save that query as a template. After running the script, you won't see results right away since the output is a view, but you can then query the view later by selecting all from the view. In the workspace, if you check under Views in the GoldDB, you'll see that the view has been created. To query it, you can simply select all from the view, and Synapse will return the results dynamically. To automate this, you can create a pipeline to create views for each of these datasets. For this example, we will do it in Synapse, demonstrating how you can manage this process within the Synapse environment rather than switching to Data Factory. In the Develop section, click on Import and import the query that will dynamically create the views. This will streamline the process for setting up similar views across different datasets. As I've mentioned in other tutorials, getting that muscle memory is important, and when you're writing out scripts, you may make small errors, which helps you catch and correct them. So, in the GoldDB, you're creating a stored procedure that accepts the view name as a parameter and dynamically runs a query, similar to the one we've shown earlier. Once the script is written, you can publish it. Then, the next step is to create a pipeline that uses this stored procedure. First, you'll need to create a linked service to connect to the serverless SQL database. In the Manage section, go to Linked Services, click the plus button, and search for Azure SQL. Choose Azure SQL Database and click Continue. Rename the linked service, e.g. Gold Auto Resolve, and select the integration runtime. Next, choose to manually enter the connection details. Go to your Synapse workspace, click on Settings, and find the serverless SQL endpoint. Copy the endpoint and paste it into the connection setup. For the database name, select the Gold DB. Change the authentication type to System Assigned Managed Identity to authenticate using your Azure email. Test the connection to ensure it works, then click Create and publish the linked service. Now, with the linked service set up, you can access the stored procedure from the pipeline. Go to the Integrate section, click Plus to create a new pipeline, and search for metadata to get the table names. Set the metadata to Get Table Names. Now, let's set up a dataset. Click New and select Data Lake. For the type, choose Binary, then create a linked service for the data lake. Browse to the Gold folder, then the Sales folder, and select the tables you want. Click OK. Once the dataset is created, you can see the child items under the Sales LT folder. To test, click Debug to run the pipeline and check the output. When it's done, the output will display the results, showing that the pipeline has successfully fetched the metadata. Output. You can see here that the child items are the name and the type. Now, we have all the names of the tables that we can use. Next, let's create a for each activity, type for, and drag the activity. On success, we want this for each to run. In the settings, go to Items and add dynamic content to get the table names dynamically from the child items. As seen in the output from the previous step, the child items contain the necessary data. Now, create a new activity within the for each by clicking the pen icon. This time, search for the stored procedure activity. Since we're using a stored procedure, you'll configure it in the settings with the link service set up earlier. Under Stored Procedure Name, click New Stored Procedure and set the name as ViewName, since that's the parameter coming from the for each loop. Set the type to string and use the value as item.name to dynamically access the table name from the child items. Once this is done, click Publish All to save the changes. However, you need to add the stored procedure name. To do this, go back to the query for the Gold DB and run it to create the stored procedure. After running it, refresh the view name and you'll see the dynamic procedure appear. Now, you can pass in the stored procedure name to the for each activity. Once everything is set up, click Publish All again to save everything. Next, go to the pipeline, click on Metadata, and add a trigger. After publishing, trigger it, and you'll be able to see the pipeline run. If there's a failure, go to the Monitor section to check the error message. You may encounter an error about a directory path not being listed, which likely means there's an issue with the storage account path. Once you identify the problem, fix it and rerun the pipeline. Once the issue is resolved, rerun the pipeline by clicking on Rerun in the Monitor section. You can choose to run the entire pipeline or just the failed activity. After running the pipeline, the status should show as successful, confirming that the process has completed without any further issues. You can see, if we click these, you can now see that it successfully ran all of the stored procedures. If we go to the data and to the SQL database, we can refresh, and under Views, we see all the views. Perfect. Something to note here is that this process doesn't need to be run every time, only when there are schema changes, not data changes. Since it's a view which acts like a layer above the data, the only time this needs to change is if the schema itself changes, not the data. Now that we've seen everything up to Synapse, let's move on to our next episode, where we'll explore how to see this data in Power BI. In episode 1, I showed you how to set up Power BI, and while you do need a work email, there is a workaround. Links in the description of that video. On the Power BI app, if you go to app.powerbi.com, you can only interact with dashboards, such as applying filters. You can't create dashboards from scratch there. For that, you do need the Power BI app, and the app requires a Windows machine. Trying to virtualize it is a bit of a hassle, so if you're not using a Windows machine, you may be better off with Power BI Table. But the best option is to install the app and sign up using the link in the description. Now, in Power BI, let's open it up to the home screen and start a blank report. To create a blank report, we need data, so let's go to the top right and click on Get Data. Then select More to open up a variety of sources we can link to. Here, we want to choose Azure Synapse Analytics SQL because we want to get the data from Synapse. Click Connect, and some settings will appear asking for the server and database details. The database we want is the Gold database as shown in previous episodes. For the server name, if we go back to the resource group in Synapse, we can find the same SQL endpoint as before. Copy the serverless SQL endpoint, go back to Power BI, and paste it in. Click OK, and then authenticate with your Microsoft account. Sign in using whichever email you use for your portal and click Connect. This will load the data. As you can see, it's loading all the tables. You can either load the data as is or transform it. Transforming the data means you'll create a series of steps the data will go through every time it's updated. For example, you can rearrange columns, change types, or rename them. This is quite handy, but for now, we'll simply select all the tables and load them in. A brief overview of Power BI. Here is the report view, which is where you work with your data and create reports. The dashboard view allows you to view your reports in a more interactive way, and the table view helps you model and manage your tables. View is where you can then view the data model, which is actually really important, and we'll get to that in a second. Lastly, there's the DAX query view, where you can write functions to query your data. DAX here is a library of functions and operators. Within Power BI, if we go back to this model, you can see that it automatically creates a model. What it does is it tries to match similar column names, assuming that certain columns should be linked together. This is important because when you run queries or filters, it helps to match the data appropriately. For example, you might have an address column that links to a customer address table, so if you filter by city, it will reflect in the customer data as well. Right now, this model might look a bit messy, but one thing to note is that these are your tables, and the lines represent relationships. The direction of the relationship indicates how the data links, and whether it's a one-to-one, one-to-many, or many-to-many relationship. For example, if you have a customer and an address, it's likely that one customer can have one address, but many customers could share the same address. To adjust this, you can go up to the top and click Manage Relationships, which gives you a clearer view. There's an auto-detect button that you can use, but it won't change anything if the relationships are already auto-detected. If we take the customer address relationship, for example, we can change it from one-to-one to one-to-many and adjust the cross-filter direction to both, so that filtering either one will affect the other. After making the change, click Save. Another concept to note, though we won't cover it here, is that in data engineering, it's important to distinguish between fact and dimension tables. Fact tables hold quantitative data for analysis, while dimension tables hold descriptive attributes related to the data in the fact tables. For example, a fact table might have foreign keys that link to primary keys in a dimension table, which holds detailed information about the items, locations, or contacts related to the facts. These relationships are crucial for building a meaningful report. So now let's move back to our report and start creating one. First, let's have a quick look at the UI. Here, you have all the elements that you can drag and drop into your report, such as different types of graphs, filters, called slicers, and other visual elements. When you click on any table, you can view its columns along with indicators showing what the key column is. To start, let's add a card visual. This is a simple visual that displays a single value. When you click on it, it opens up a card. You can then adjust its settings, including formatting the visual and selecting the fields you want to display. For instance, you can click on a field like LS and drag it into the card to display that value. What we can do is let's add the product ID, drag that into the field, and you can see here it's automatically chosen as count. You can choose other options like sum, for instance, but in this case, it doesn't make sense to sum it. If you count it, you can see the number of product IDs. What we can do here is switch off the category label, that count label, and then go to General, where we can turn on a title and call it Number of Products. The title will pop up, and you can customize the title with colors, background color, etc. Now that we have that card, let's press Ctrl+V to duplicate it. In the second card, let's change the value to the sum of sales. We can clear the field on the left and then go to Sales Order Detail. We can drag Line Total into the field and it will show the sum of the line total. Now, we go to the Visual Settings, under General, change the title to Total Sales. Now we have two cards, one for the number of products and another for total sales. You can resize them and place them wherever you want on your report canvas. Let's go back to the business request and check what's actually creating this dashboard. We're building a dashboard to display the total number of products and total sales, and it should also have a clear gender split among customers. We want to be able to filter by product category and gender. Let's first work on the gender split. We'll create a donut chart in Power BI. In this donut chart, we'll use customer data to infer gender based on titles. We can add the title field into the values and details areas. This will give us the breakdown of customers based on titles, allowing us to see the gender distribution. It appears that the majority of customers are male based on the titles, but we have a variety of products with 295 different products listed. Next, we can add a filter for products. We'll create a slicer, which is a filter element. We'll make it larger so it's easier to interact with. This is just a simple setup to filter the report by category and gender. Do any visualization or best practices. This is just so you can see what's happening. In here, let's do one with the title. We'll drag that into the field, then do another slicer just for sizing. Ctrl+C and Ctrl+V to duplicate, then line them up. For the second slicer, uncheck that, go to the product category, and select the name field. Now, we have a variety of product categories. We can move these two slicers over, make the title slicer smaller, and make the product categories slicer bigger since there are a lot of categories. Now, in this visualization, we could say, what about breaks? So you can see here that breaks affects the products. There are two products for breaks totaling $830 or pounds, but you can see that it's not affecting the sales chart. This is because of the importance of the model view. If we go back to model view, we'll see that there is no connection between customers and categories. I suspect that's the issue. We can check the relationships to confirm. You'll see that the customer table doesn't have any relationships connected, which is why changes made to customers aren't affecting the categories or sales. To fix this, we can go back to the relationships view, manage the relationships, and then create the necessary links. Once we've created the relationships, you can go back to the report. Now, if we click on breaks, we'll see that the data is reflected in the product, sales, and chart visualizations. The same goes for the title filter. If we change the title, the data updates accordingly. For example, if we select mountain bikes, we can see a gender split, 87.5% male for that category. We can also adjust the slicers to display specific information like the total sales for selected products. For example, selecting mountain bikes shows total sales as 150K. Now that the dashboard is created, we can save it as a Power BI workbook. We also have the option to share or export it. If we share it, others can access the file. We can export it to PDF if we want to send a static copy, or we can publish it to Power BI. Once published, we'll get a link to the dashboard where people can interact with it. If you want someone to have an interactive copy, share the published link. If you just want them to have a static copy, you can export it as a PDF. Alternatively, you can share the file for editing purposes. We're going to cover how to automate this pipeline so that it works on a schedule, so every day it will get the latest data from the SQL database. We're also going to cover Azure Active Directory, IEE, Entra ID, so that we can configure different levels of security for the different services for different groups and teams. So let's get into it. Let's start with our end-to-end pipeline testing. We ended last time with our Synapse stuff. So let's go back to the portal. We'll go to Home and then to our resource group. Let's get Data Factory up, not Databricks, and launch the studio. Click on Trigger New and Edit, and let's create a new trigger. There is one here, but let's create a new one. That one was from a previous one I had tried. Let's write daily trigger, and I'll just do 2. You can give a description if you want, but you don't have to. Type schedule, because that's what we're going to do. Scheduling is the best one, because you can do it at time intervals, which is what's most appropriate normally. Now, for the start date, just leave it as is. That's detecting it as being right now. The time zone is fine as UTC +1. In recurrence, we want this to run once a day. We'll also specify an end date, so we'll end it tomorrow. For the execution time, we want it to be executed at 17:12, which gives enough time, and then we click OK and OK again. After that, we publish it, and it will publish the trigger on this specific pipeline. While waiting for that to go, we check the trigger. You can actually attach or detach triggers. That daily trigger you see here can be detached. So now there's just trigger 2 on it. If I check new and edit, this is just that one, but I can also add on that other one as well. Now let's open SSMS. We'll also open the configuration management to make sure that it's running. And yes, it's still running, which is good. Let's wait for SSMS to load up. I'll connect to our standard server, the one we had installed in the first episode. Now, let's open databases, and we'll open our AdventureWorks database. We'll go to tables and then update the product table. If we right-click, we'll script the table as and do an insert to open a new query window. We're going to insert something here, so it will change the number of products you can see in Power BI. Currently, there are 295 products. Let's remember that number. The script gives us a standard format with the values we need to add. The link to the GitHub repository will be in the description where you can find this. I'll just open it in Notepad and paste these values in. The product values look good, and we can proceed from there. Now when we execute this, it will create a new role. Let's execute it once. There we go. If we do name just for demonstration purposes, the product number also has to be different. There we go. It's inserted 2 rows, so we should now expect this to go from 295 to 297. While we're waiting on these changes to happen, that was much faster than I thought it would be. Let's now have a quick look at Entra ID. If we come back to the Azure portal, we'll go to the resource group and select RG, then go to IAM, Identity and Access Management, and Role Assignments. When we're in here, if you have a company, there will be multiple people, maybe even many groups of people with access, because people will be leaving and joining teams, etc. One way you could do this is by assigning each individual person specific access. You could add the role and just assign it to the one user, but as you can imagine, that's pretty messy. This becomes complicated, especially with people moving from one project to another, leaving or joining the company, etc. So instead, what we can do is create a security group, which would be a logical grouping of individuals requiring the same level of access. We can then assign permissions to that group. For example, instead of just adding access to individuals, we could assign the data engineering team access to this resource group. To do this, we go to Entra ID, Previously Active Directory, click Add, and then select Group. We want a security group, not a 365 group. The group name will be Data Engineers, and for the description, we'll write Data Engineers. Under Owners, you would want to select the admin. In this case, I am the admin, so I'd select myself. For the members, we can select users or groups. The only user here is me, but if you had other people, you could select them under users or groups. Once you've selected the necessary members, click Select and then Create. Now we've created a security group, which I am the admin of. I can add or remove people as needed. What this means is that if we go back to the resource group, we can now add a role assignment to this group. For example, If you want this group to only have access to the storage blob in the data lake, you would select that and click Next. Here, you can select the members. We can select the Data Engineers group, click Select, and now the data engineers have the storage blob data contributor role. If we review and assign it, these members will now have that role.
Access to the resources within the group can be seen here under Role Assignments, Storage Blob Data Contributors, Data Engineers. This shows how powerful it can be when you have a variety of teams needing different levels of access to various resource groups. Resource groups aren't just used for projects. You can logically group things together for larger projects. For instance, in this resource group, if we were using proper server architecture and had VNets, you could have a resource group that holds your virtual networks. This way, the networking team could have access to that, while the application team dealing with virtual machines would have a different grouping. You can see how powerful this becomes when you scale it up to teams. We're still at 702, so let's go ahead and change the trigger. Let's edit this trigger to run at 503 or 504 now. Actually, if we do 503 and set it to 449, that should be good. Now let's publish it. I'm a bit worried about the time zone issue as we are in UTC+1, which messes things up. Anyway, let's go to the monitor and see if it works. So still nothing at 504. I think it's because of the time zone. It was detecting me as being at 350, but that's not right. Let's change it. I think the time zone issue with UTC+1 is causing the problem. We could set it to UTC, but for now, let's change it to 4 RAN and try again. Let's see if it works now. It turns out the time zone is still messing things up. It's saying UTC+1, but it's actually 505. So I need to fix this issue before it will work properly.
What we're going to do is set it to 406 and leave it until the end to ensure there's enough time for it to publish. Once that's done, we click OK and publish it. If it publishes within the next 10-15 seconds, it should pick up the trigger. Let's go back to the monitor, refresh it, and wait for a minute before refreshing again. After refreshing, we can see that the pipeline hasn't run yet. I believe it's still due to the time zone issue. I didn't mean to click debug, so let's cancel that and go back to the monitor. Now after refreshing again, we can see that the pipeline has been triggered. If we click on the pipeline name, we can watch it run. As it goes through the steps, once the copied data is done, it moves on to the notebooks. After a minute, the notebook will load. Once the notebook is loaded, we'll see that due to a timeout on the bronze and silver notebook, the process is delayed. We're waiting for the compute resources to spin up before we can run the notebook. After almost 5 minutes, the notebook is now accessible. Once logged in, it will likely be completed by the time we finish these steps.